friends, this is Abhik from Bangladesh, and in this video I'm going to show you how you can run regression analysis in Eviews and the interpretation of the regression outcome. So let's start our main portion of this video. So here is my data set. Let's open it and minimize the command window. I have three independent variables, x1, x2 and x3, and one dependent variable which is called y, and let's open them in a group. So y is my dependent variable and x1, x2, x3 are the three explanatory variable or independent variables. To run the regression in Eviews, we have to go to quick, click on the quick option and then click on estimate equation. And the rules here to run the regression model is that at first you have to write the name of the dependent variable, which is y for my model. So type y, then there will be a space and type C. C stands for constant, and this constant is for the regression equation, and there will be another space. Then there will be the independent variables one by one, and each will have a space with them. I mean, now the first independent variable, which I'm calling x1, type x1, then a space, and then the second independent variable x2, and lastly the third independent variable x3. It's not a matter if you type x3 in the position of x1 or if you type x2 in the last position of x3. It's not a matter, but you have to have the independent variables with a space. And then what you have to do, click on the button OK. So here is my outcome, and now we have to interpret this outcome, but the fonts are so small. For the convenience of the viewers, I will copy it, Ctrl A, copy, then copy, and I will paste it in MS Word, and here the fonts will, the fonts are now larger, and bring it in the middle. Now we have to interpret this regression outcome. Before interpretation, we have to know that we will not interpret all the statistics in this outcome, but we will interpret only 1, 2, 3, 4. We will interpret only 4 things from this output or result. And what we'll interpret are the probability values, I mean this column, the values of r squared and adjusted r squared, I mean these two lines, and lastly we will interpret the state of Darwin-Watson state, and that's it. We'll not interpret other statistics because these are not so important to interpret, but if you want you can interpret. But I'm not going to show you the interpretation of this, I mean the other statistics of this regression outcome. So let's start the interpretation. To interpret probability values of each of the independent variables, we have to know that if the probability value of a independent variable is less than 0.05, then the respective independent variable is important or significant for this model. Or we can say, if the probability value is less than 0.05, then the respective independent variable explains the dependent variable in a good way. I think it's clear now. And if it is not, I mean if the probability value is greater than 0.05, then that certain that certain variable, I mean that certain independent variable is not so significant or insignificant for determining dependent one. So what we see here is for x1 the probability value is 0.0267, which is less than 0.05. It means this variable, I mean x1, determines y in a good way. So x1 is a significant variable, significant independent variable for this regression model. Then it comes to x2. For x2 we see the probability value is greater than 0.05. The probability value of x2 is 0.7515, which is greater than 0.05. So x2 is not a significant independent variable for this regression model, or we can say x2 doesn't determine y in a good way. And for the third independent variable, we find the probability value is 0.0373, which is also less than 0.05. So x3 is also a significant independent variable to determine y, or x3 is also significant variable or important variable, we can say. So from here, by interpreting the probability values or significance of the independent variables, we can say x1 and x3 are the significant variables. Those determine y in a significant way, and x2 is insignificant here. Then come to the next section, I mean this portion, and here we will determine, as said before, we will interpret the values of r squared and adjusted r squared. These two values talks about the same result, but there is some kind of fact that adjusted r squared is more acceptable than r squared. The interpretation is that the more the value of adjusted r squared or r squared, the more fit the model is. Otherwise, we can say just by looking the value of r squared or adjusted r squared, you can determine whether the model is a good one or not. From here we can say, by if we consider r squared, we can say this model is a good one because the independent variables here cumulatively explain 93.49% of the dependent variable. On the other hand, if we consider adjusted r squared, then we can say the independent variables cumulatively determines 90.2417% of the dependent variable. I think it's clear. We can interpret in another way, just like the r squared is saying this model is 93.49% fit, and the adjusted r squared value is saying this model is 90.2417%. The more the value of r squared or adjusted r squared, the more fit the model, the more good the model. You can consider R squared or adjusted R square, but I will suggest you to consider adjusted R squared value. So I think it's done. And the last one, which is going to be interpreted, is the Darwin-Watson state. With these statistics, we can determine whether your dataset has autocorrelation or not. And the guideline is here, if the value of Darwin-Watson state is less than 2, then there is positive autocorrelation. On the other hand, if the value of Darwin-Watson state is greater than 2, then there is negative autocorrelation. And finally, if the value of Darwin-Watson state is 2, then there is no autocorrelation, which is supposed to be for the dataset of a good regression model. I mean, for a good regression model, the Darwin-Watson state has to be 2 only. But in this model, what we see is Darwin-Watson state is showing my dataset has negative autocorrelation because the Darwin-Watson state is greater than 2. So though this model is a good one according to the value of R squared and adjusted R squared, but the Darwin-Watson state is saying this model, I mean the data of this model has autocorrelation problem. However, it's not a matter because these are just tests and we cannot manipulate the real data, and that's very unethical. So it's okay to get if your data set has any kind of autocorrelation, I mean positive or negative, that's not a matter, but overall this model is a good one. I mean this regression model is a good one. So in this way you can interpret your regression result, and if you have any question or if you have any query, feel free to ask me in the comment section. And finally, thanks for watching this video.